Good afternoon, grade 11. Good afternoon. Today I'm going to continue. Remember, this is the paper that I've already uploaded. I did question 1.1. If you can still remember, I did question 1.1. You can still remember. It's on my TikTok. You can just check. I did question 1.1 and 1.2. So today I'm going to continue now and look at what we call the Fohn winds, representation of the Fohn winds. This is something that you did in term 1, the Fohn winds. Okay, the Fohn winds. So the Fohn winds, guys, is something that also is done in grade 11 under the atmosphere. So we need to understand what Fohn winds are. So the general idea, I'll give an example of, let me give an example of an orographic rainfall, which is more like a relief rainfall. Let me put it that way, so that at least you have an idea of why this takes place. Okay, or I'll take you back to grade 8. You still remember when you're looking at factors that affect temperature and rainfall. You still remember we looked at the latitude, we looked at altitude, we also looked at mountains. I'm more concerned with mountains. Where we say that if we have got a diagram like this, what is the effect of the mountains? We say that we have got warm air that is coming from the sea. What does it do? Warm air by its nature, okay, is very light or less dense. So what does it do? It rises on what we call the windward side. We call this one the windward side. So this is warm and moist. I want to use this just to simplify the Fohn winds. I'll get to the Fohn winds, what it is, I'm going to define, but I want to give you an idea, a recap. I'm just taking you back to grade 8. So the warm moist end, what does it do? It rises, okay? It cools. It condenses, okay? When it condenses, what happens? Clouds form. Then we have rainfall here on the windward side. So the same parcel of air that is risen from the windward side, it continues to rise. Then what is happening on the windward side is there is a drop in temperature by 1 degree for every increase in altitude of 100 meters, which is what we call adiabatic cooling, or we call it the wet adiabatic lapse rate. So there is a drop in temperature with an increase in altitude, which means for every increase in altitude of 100 meters, the temperature drop by 1 degree Celsius. Okay, so the warm air, as it is rising, what does it do? Warm moist air is less dense. What does it do? It rises, it cools, condenses. Then we have got these clouds. Then we have got rainfall on the windward side. Do you still remember? Then the same parcel of air, as it is rising on this side, which we call the leeward side, or we call it the rain shadow. What is happening on this rain shadow is the opposite of what is happening on the windward side. So for every decrease in height, decrease in altitude, let me say altitude, that's the right geographical term. So temperature drops, okay? Temperature drops or increases, sorry. Temperature increase by 1 degree Celsius, which is called the dry adiabatic lapse rate. So it means the temperature, as it is ascending, the temperature is increasing by 1 degree for every decrease in altitude of 100 meters. That's what we call the dry adiabatic lapse rate, which means the temperature when it reaches here, it is very high as compared to what it was. Let's say it's 20 degrees here, all right, 20 degrees Celsius here. Here, we can say it can be higher. Of course, I'm just giving you this as an example. 30 degrees. Why? Because the air that is still moving on the leeward side is warmed up adiabatically. As it is warmed up adiabatically, it means now the temperature is increasing with a decrease in height on the leeward side, but on the windward side the temperature is dropping with an increase in size. So this is more or less what you do when you're looking at the effect of mountains on climate and also on rainfall, okay, on temperature and also on rainfall, which means here what is happening, temperature is dropping with an increase in height, which is what we call the wet adiabatic lap rate. Wet adiabatic lap rate, okay, or adiabatic cooling, which means for every increase in temperature of increase in altitude of 100 meters, the temperature drops by 1 degree. Here, for every decrease in temperature of 100 meters, the temperature increased by 1 degree. Here there is adiabatic warming, which means that same parcel of air, as it is descending, the moisture that is left within that parcel of air also evaporates. Why? Because it's being warmed up. Remember, when it gets here, it's now cold. What does it do? It sinks. Okay, so when it's sinking, which means obviously there is an increase in temperature with a decrease in altitude. For every 100 meters, the temperature increased by 1 degree. So this is more or less the same concept. I wanted you to have an idea. I take you to grade 8, where you're looking at the how mountains affect temperature and rainfall. So this is more or less the same concept. So our Fohn winds, these winds have their origin in the Alps in Europe. These winds have got their origins in the Alps in Europe. I'm talking about the Fohn winds. They've got their origins in the Alps, Europe. And the winds, they are very warm, dry gust winds which blow from the windward side of the mountain to the leeward side of the mountains. So you can see what I was saying, it blew from the windward side of the mountain to the leeward side of the mountain. That's how they move. These winds are dry, warm, dry, and gusts which blow from the windward side of the mountain to the leeward side of the mountain. The same concept I was explaining here. This is the windward side, this is the leeward side. So it starts off here until it gets to the leeward side. Here, the temperature is dropping, and also it releases moisture. Why? Because it is warm and moist. It rises, cool, condenses, clouds form. We have got rainfall here. But the same parcel of air, as it is moving the wind, of course, here now, as it is descending, there is an increase in temperature with a decrease in altitude, which is for every 100 meters, then a decrease in altitude, the temperature increased by 1 degree. So that's basically what we're talking about. So you can recall from what you did in grade 8 when you're looking at the factors that affect temperature and rainfall. Remember, we looked at latitude, we looked at the mountains, we looked at altitude, we also looked at the ocean currents. You still remember, those are some of the things that we look at, but here the focus is on mountain. This is how it takes place. So it is the same wind that is warm, dry, and gust which blow from the windward side and of the mountain to the leeward side. That's basically what I was explaining here. So let's go to the question. Why is Fohn wind an example of regional wind? Why is it considered a regional wind? So the answer there, it affects small areas and only blows at certain times of the year. It affects small areas, so it affects small areas and also blows on certain times of the year. That's why it is called a regional. So it affects small areas and blow on certain times of the year. That's why it is called a regional wind. Okay. Name the side of the mountain at B in the formation of Fohn winds. The side of the mountain at B in the formation of Fohn winds. This one is called the leeward side. This is called the leeward side, and this one is called the what? The windward side. This is called the windward side. This is called the windward side. This is the leeward side. So this is the leeward side. Okay. Why is there no rainfall at B? Remember, at B, what is happening is, as it is descending, the temperature increased by 1 degree for a decrease in altitude of 100 meters, which means it is warmed up. As it is warmed up, obviously moisture, what does it do? It evaporates. Okay, that's why there is no clouds formed. That's why we do not have rainfall on the leeward side. Number 2, it is also adiabatically warmed. Remember, we said for every drop in 100 meters, the temperature increased by 1 degree Celsius. So thus we do not have rainfall on the side B, which is the leeward side. Describe how rainfall is formed on the ascending warm air at A. We are saying now at A, what is happening? There's moist air. Remember, we said there's moist air, warm moist air. What does it do on the windward side? What does it do? It slides, it rises, cools, condenses, clouds form, then we have got rainfall. That's what is happening. Remember, we talked about the wet adiabatic lap rate. For every increase in altitude of 100 meters, the temperature dropped by 1 degree Celsius. Okay, so this warm moist air is laden with moisture. So what it does is it is rising, it cools, it condenses, clouds form, then we have got rainfall on the windward side. This is what happens. This is what happens. And you've got, it's evident that you've got the clouds at A. We also have the rain. That's what happened. So the warmest A, what it does is, as it rises, it cools, it condenses, clouds form, then we have got rainfall. The evidence of the rain and also of the clouds at A. This is what happened. Then in a paragraph of approximately 8 lines, explain the impact that the descending A at B will have on people living. This is the effect on people that are living on the mountain, which means we are talking about the people that are living here. The people that are living here. Remember, we have highlighted that it is associated with high temperatures, which means we are likely to have veld fires. It's a possibility. So there's a possibility of veld fires that can cause destruction. There's a possibility of veld fires that can cause destruction. That's one thing that we can talk about. There's a possibility of veld fires that can cause destruction, and also the crops can dry out, affecting agriculture. It's affecting the livelihoods of the people. Remember, we are saying the people living in the mountain side of the mountain. So their livelihoods are likely to be affected because the veld fires can either cause the crops to dry out, which affects the agriculture. And you know that this is where they get most of their income. So if agriculture is going to be affected negatively, so that's what is likely to happen. So it can also cause high dehydration to the children and the aged people, because the temperatures will be unbearable. The temperatures will be very high. So it can actually cause dehydration because the temperatures will be unbearable. Okay. Then it can also cause snow to melt in certain countries, causing avalanches and floods. Remember, we said that it is common in the Alps in Europe. So it can actually result in snow melting in certain countries, called avalanches and floods. So we can also have floods. That's how it can also, the floods, you know, the impact of floods, people can die, it can destroy infrastructure, it can destroy people's houses, it can also have a negative impact on the livelihoods of the people. Due to the floods, avalanches can cause widespread destruction and even death. People can die. Then crops can also be washed away. So these are some of the things that you can actually look at. So you can see the way I've been explaining this. I have been explaining my points in full, which is point and a qualifier. I've been explaining my points in full, which is a point and a qualifier. So the next thing now is we have got the next question that it illustrates what the LaNina process. The LaNina process. This is something that is also covered under the atmosphere in grade 11. Illustrate the LaNina. We have got the El Nino and LaNina. I think you need to have an idea of what these two are all about. So the El Nino, this is when the ocean's surface are warmer than usual. They are warmer than usual. That's what we refer to as the El Nino. And when you talk about the LaNina, this when the ocean surfaces are cooler than usual. So this results in different weather conditions. This results in different weather conditions. Like you can see here, if we are saying that the warm ocean is cooler than normal, which means we have got warm in, which means our trade winds are very strong. That's basically what we are talking about, which means the likely weather conditions that are likely to have strong trade winds, the equatorial strong current. Of course, we are having, I'm going to talk about it as I'll be answering the question. But when you talk about LaNina, the warm ocean is cooler than normal, and it results in certain weather patterns. And we talk about the El Nino, the warm, the surface of the ocean is actually warmer than normal, and it results in certain weather pattern. Remember, our warm results in low pressure and our cold results in higher pressure. So you can have an idea of what is likely to happen in as far as the conditions that are created as a result of El Nino, where the ocean surfaces are warmer than usual. We are talking about the Pacific, obviously, and also the LaNina, where the warm oceans are cooler than usual. Okay, so let's go to the question. Why is the LaNina process described as a weather pattern? Why is it described as a weather pattern? It causes short-term changes to the climate. It actually causes short-term changes to the climate, which means when you look at the conditions that are taking place here, there are changes that are taking place. Obviously, there is your low pressure. It's coming from here, of course, cooler than normal, which means this becomes a higher pressure, and where it's warmer here, it becomes what? Low pressure. It's moving from here going towards that. That's basically what we are talking about. So it actually causes short-term changes to the climate. It causes short-term changes to the climate. That's what is referred to as a weather pattern. Gave two pieces of evidence in Fig 1.4 that indicate that the LaNina process is being illustrated. Remember we said that it's cooler than normal, cool water at the surface. So, of course, what are the likely weather conditions that we are seeing? We are going to have strong trade winds. You can see on the diagrams, we have got the strong equatorial current. You can see also we have got the low pressure that we have over Australia. So these are the weather conditions that we have, the piece of evidence that indicate that LaNina process is being illustrated. You can see the surface here is cooler than usual, which creates high pressure. You can see now, that's why we have got high pressure. We've got the strong Peruvian current here. That's what creates high pressure. And in terms of our pressure gradient, it moves from high to low. So which means there's low pressure here, there's high pressure, because there is cooler than normal, which means this makes this one warm. So low pressure, high pressure, it moves from here up to there. So there is low pressure of Australia, the strong trade winds, and strong equatorial current. Okay, this is what we are seeing from here. Okay, then the skywise, the eastern half of Australia would receive heavy rainfall during the LaNina process. The eastern half, okay, the eastern half of eastern would receive heavy rainfall during the LaNina process. So this is Australia, this is west, this is east. Why is it going? Why the eastern half of the Australia would receive heavy rainfall during the LaNina process? What is likely to happen? 1.4.3. The warm temperatures over Australia, warm temperatures. That's why we have got low pressure here. Warm temperatures over Australia causes a low pressure to develop. What does it do? It causes a low pressure to develop. The warm temperatures over Australia cause the low pressure to develop. That's why we have got low pressure. We are saying warm temperature. Why? Because of the difference. You can see in terms of here we have got cool water, there we have got warm. So the warm temperatures cause the low pressure over Australia. The strong trade winds, you can see the strong trade winds. Easterlies winds push more water than usual westwards, which means it's pushed towards this side, it's pushed westwards. Okay, the strong tropical westerlies winds push warm water than usual westwards. It's pushed towards this side where we have got our Australia. Then large scale evaporation and condensation. Okay, large scale evaporation and condensation. Okay, you know what happens when condensation. Okay, then Australia would experience above average rainfall. This is what happened. Then the last one, explain the economic impact of the LaNina process have on Africa. What impact does it have on Africa? Now, what impact does it have on Africa? You have got our East Australia, which means Africa is on the other side. What impact does it have? So we are looking at situations like, okay, the eastern half of Africa may experience more heavy rainfall. It's likely to have floods. It's likely to have floods. The eastern part of Africa is likely to have floods that are more than usual. These floods would actually fill dams and increase the availability of water. You're looking at the economic impact. So I'll say we are likely to have floods, and these floods are likely to fill up dams. Then we have got an increase in the availability of water. That's what will happen, which means if we have got more water now, we have got more water that is available for industrial, domestic, and agricultural use. That's what will happen. We have got likely to have floods. The floods will fill up the dams. Then we have got more water available, which is raw material mostly to the industries. So we are likely to have more water to the industry, domestic, and the agricultural use as well. So that in itself, what will it be the impact? Which means we are likely to have more or greater food production than the subsistence and commercial farms, because we now have more water that is stored in dams. We have got availability of water. There's likely to be improvement in terms of the agricultural productivity. There's likely to be an increase. The food will also be cheaper and more accessible, because now we are able to farm. We have got enough water for irrigation. We have got enough water to farm. So we are likely to have cheaper food. And it's likely also to be accessible, because we have had an environment that is conducive for better agriculture in terms of productivity and yields as well. And also we can also increase the number of imports to a country. The number of imports to a country will also be reduced, because we are not going to import food now that we have got reserves. We are not going to import food, which means now we reduce the number of imports in as far as food is concerned. There's also more income that is also created for tourism. There's also more job security in farming and industry, as more people will actually be employed in the agriculture sector and also in the industry, since they have got more access to water. So this is how you are supposed to answer this question. Let's move on to the last part, which covers the desertification. Extract on desertification. Let's go through it. It reads, Africa's ambitious Green Belt project. The 15-kilometer A wide Great Green Wall project stretches over 7,775 kilometers from Senegal to the Atlantic, Eritrea on the Red Sea. The aim is to curb the Sahara Desert spread, but major challenges remain. The change in climate and weather patterns is triggering a rapid spread of Sahara Desert, invading into lands and surrounding huge lakes, according to the climate scientists. Several countries in the Sahel region are located just south of Sahara, therefore initiate a project that will see billions of trees planted across 11 countries by 2030, which will serve as a buffer zones to stop desertification. The African Union launched an initiative in 2007 under the name Great Green Wall. The Great Green Wall is more than just an environmental project, but intended to restore the 100 million hectares of fertile lands in the Sahel, and in the process cut 250 million tons of carbon dioxide from the atmosphere. It aims to create 10 million so-called green jobs. So this is our extract. This is the information from our extract. So when you've got information like this, please make sure you go through the information, you read to understand, because I was highlighting to indicate some of the most important points. So let's move on to our question. According to the Fig 1.5, what is the main aim of the green green belt project? What is the main aim of the green belt project? Let's go to the extract. So you can see here the main aim was to curb the Sahara Desert spread. That is the main aim, to curb the Sahara Desert spread. That is the main aim of the green project. Okay. And then the next question reads, what is desertification? So desertification is a process where once fertile areas become arid. It's a process where once fertile areas becomes arid, which means if you look now at mostly, let me talk about, okay, let's say there are some areas due to climate change that used to have, maybe they were used to look like maybe like the tropical rainforest. Because of the cutting down of trees that is taking place, you would find that they are now being changed from tropical rainforest to semi-arid to arid. That is how the process of desertification works. So we are saying that this process were once fertile areas, but now they are becoming arid. They are desert-like climatic conditions that are actually spreading in as far as those areas are concerned. That's what desertification is all about. A desert, of course, we are talking about high temperatures, we are talking about it being arid, little or no vegetation. So those conditions are spreading. This is what we define as desertification. That's what desertification is. Then 1.5.3, quote a statement from the extract that lists possible natural causes of desertification. What is possible natural causes of desertification? Let's check from what we have. Let's check from what we have. What do we have from our extract? What do we have from our extract? Because remember, the answer is supposed to come from here. Change in climate and weather patterns. Change in climate and weather patterns. This is what actually, this is the answer from the extract. Possible natural cause of desertification. So it's change in climate and weather patterns. Change in climate and weather patterns. That is the answer. Name 2 human activities that contribute to desertification. What are the 2 human activities that contribute to desertification? We are looking at overgrazing. We are now talking about a situation whereby we exceed the carrying capacity of the land where the animals are grazing. If we have got more animals, okay, which means the grass is not given enough time to regrow. So at the end of the day, that is overgrazing. That's basically what we are talking about. So that's one thing that we can also talk about, overgrazing. We can talk about overcultivation through maybe monoculture, growing one crop year after year. That in itself also, okay, overcultivation. Okay, no, overcultivation, which means we are ending up cutting down trees. Okay, let me put it that way. No, it's not monoculture. Okay, overcultivation, we end up cutting down a lot of trees. In that way, deforestation is also spreading actually the desert-like climatic condition, which is what we refer to as desertification. Deforestation, that's another one. We can also talk about poor irrigation practices. Remember, we are also concerned about the change in terms of soil fertility. So we can also talk about poor irrigation practices or poor agricultural practices as contributing factor, human factors to desertification. Then discuss how the planting of trees can serve as a buffer zone. So the planting of trees, how does it serve as a buffer zone? Trees actually promote infiltration and less surface runoff of fertile soil. That's how it actually aids as a buffer zone to manage desertification. So they promote infiltration. Just imagine where the area is forested, which means when it rains, the water, the pressure at which the rain reaches the surface, as the water is intercepted, it allowed to infiltrate and surface runoff is reduced, which means there's more infiltration that is actually encouraged to promote more infiltration, less surface runoff, which means it maintains the soil fertility. The trees also act as windbreaks around fertile soil. It also acts as windbreaks around fertile soils, which means we are also trying to manage desertification. Okay, trees also provide a shade and create a nutrient link. That's what it does as well. Trees also increases evapotranspiration, therefore we have got more rainfall. Remember, the desert-like climatic conditions, we are likely to have more rainfall, little or no rainfall like what we have in the desert. So if we have got more trees, which means we are likely to have evapotranspiration, which aids to the moisture in the atmosphere, clouds build up, then we are likely to have more rainfall. So that's how planting of trees can actually aid as a buffer zone to manage desertification. Besides afforestation, explain two other ways in which desertification can be managed. We are now talking about 1.5.6. We can talk about proper soil management that include the use of organic fertilizers. That's how we can also try to make sure that ways in which desertification can be managed. Proper soil management that will include the use of organic fertilizers like animal manure. We can also actually use compost. Then when we take the leaves of the plants, okay, we create compost. We can also use that as organic fertilizers. Soil management that will include the use of organic fertilizers. Okay, we can also enforce the law to encourage sustainable management of resources. We can enforce the law to actually encourage the sustainable management of resources. That's something that we can also do. We can also, land management, encourage the growth of drought-resistant crops. Drought-resistant crops, some of these drought-resistant crops, they've got early maturity, which means they are able to mature with little or no rainfall. They are drought-resistant crops. So that in itself can also help us to actually, is a way of in which desertification can be managed. We can also allow land to lie fallow, which means we are not plowing a land for a certain period of time so that it can recover naturally. That's basically what we're talking about. Then lastly, comment on the positive impact that the Green Belt project would have on the people living in the region. What are the positive impact that this project will have on the people living in the region? So the first thing is it can help to job creation, employment creation, which is that's how it can also help the project, a positive impact of the project. Employment creation, you remember it says here it aims to create 10 million so-called green jobs. So it helps in employment creation. It can also restore millions of hectares of fertile lands. It can restore millions of hectares of fertile lands. Here, restore millions of hectares of fertile lands. That's what it can also do. It will also decrease food insecurity and famine in the Sahel. There will also be a reduction in land degradation. That's another thing. There will be a reduction in land degradation. It will help to reduce conflict in the region. It also reduce mass migration from countries in the Sahel to other countries. So these are some of the benefits that can also come as a result of the Green Project. I think this takes us to the end of our paper 1, Geography Grade 11. I have done 1.3, which covers Fohn winds, and 1.4, which covers LaNina and process, and the last part, which covers desertification. Thank you so much. Go through the paper. If you've got any challenges, please let me know. Danko.